So today we see about the 20ME601 metrology and measurements. So already we discussed in before videos last three units. Now we go for the unit 4 measurement of mechanical parameters. So first we know about the mechanical parameters. So here this uh, torque and force and temperature, these three mechanical parameters, how to measure and what kind of equipments we going to use for measuring these mechanical parameters. So these things are we discussed in this unit. So first one we go for the measurement of torque and temperature measurement and measurement of force. So these three things are we discussed for this topic. Next one, the torque measurement. The torque measurement is the first we know about the torque. The torque is a rotational force. So where we are the power transmission and also that rotational moment where it is taken is how the measurement is done by this equipment. So here we go for the Prony brake arrangement. The Prony brake arrangement is shown in figure. So here we have the spring balance and also the rotating brake dam and dead load. So the dead load is given the rotating brake dam. The brake dam is we have attached to the spring balance. Here the working principle of the brake dam Prony brake dynamometer, the load cell to apply the diode. We have the four diodes. The four diodes we have the electrical signal to the applied to the these four diodes. When we go give the load or rotational movement, the diodes or resistance are expanded. So these electrical resistance to be measured by the measurement. So here the torque is measured, and next one, torsion bar torque transducer. Here the transducer diagram is shown in figure. We have the two transducers. The first one is observer and second one is light source. Here the light source are how they reflected to the observer. It will be to measure the torque of the shaft. And next one is laser optical torque measurements. Here the optical stickers are sticked in the shaft, and also the laser transmitted that laser light is transmitted to the sticking the shaft, and the measurement is done by the this rotational to the shaft. And the next one is proximity sensors for the torque measurement. Here we have the sensors, two sensors fixed in the toothed wheels. So the rotational moment taken into the shaft means the rotational that proximity sensor sense and displayed the output of the unit. So these equipments are measure the torque. Next we go for the temperature measurement. Temperature measurement, the bimetallic strip thermometer and thermocouple and thermometers, thermistors and pyrometers and resistance temperature detectors. These equipments are to measure the temperature measurement. So first we go for the bimetallic strip thermometer. Here there are two types of material. That means thermal conductivity, high thermal conductivity material and low conductivity material are combined together to attached in the given zone figure diagram. So here where the material to be applied to the temperature, so the temperature is measured for conducting our bimetallic strip to contact with the wire. This the bending moment when the temperature is increased, the metal contact is disconnected, and the metal temperature is reduced, the contact will be to the object. So this principle to follow the to measure the temperature and the so next measurement is thermometer. So we know that the thermo thermometer liquid, that means mercury, it will be expand easily and to conduct the temperature. This mercury liquid is into the glass tube, so the temperature in our body temperature or atmospheric temperature, it will be to expand the thermo mercury and to find the value of the indicating the readings. So this is the working principle of thermometer. Next one is resistance temperature detector. So here the temperature bulb, RTD bulb, will be a temperature resistant temperature detector. So here the three resistance are used for the RTD. So two, the one is fixed resistant and remaining two is expanding resistance. So here the temperature is increased, the expanding temperature resistance is increased, the voltage also increased. This fluctuation to measure the temperature. And next one, thermocouple. So here the thermocouple have the two junctions, hot junction and cold junction. These two junctions, uh, the temperature difference is to indicate the temperature. So this is the basic principle of the thermocouple. So next we go for the field thermal systems. So this thermal pressure bulb is to developed in the temperature measured temperature objects, and then the thermal uh, the temperature device is sensible, the physical quantity is transferred to the conversion, and finally we go for the pointer or presentation element. This presentation element, we know the temperature of the liquid. And next one, total radiation pyrometer. The total radiation pyrometer is working on the radiation of the temperature. Here we have the two junctions, hot junction and cold junction. The total radiation, we have the temperature source and protection radiation shield and concave mirror and millivoltmeter and housing tubes. Here the temperature is focused on the uh, protection radiation shield at the point of the hot junction of the thermocouple. So the hot junction and cold junction temperature difference is to measure the total radiation pyrometer. So next one, infrared pyrometer. Here the principle of visibility of the light to measure the temperature. And electrical resistance or electrical resistance thermometer. Here the thermometer is disc type thermistors and also lead wires and Wheatstone bridge to measure the resistance changes. So the Wheatstone bridges to measure the small changes in the resistance. It will be measure the the temperature. And optical pyrometer. This optical pyrometer to measure the visibility of the light. So for example, equal brightness means the temperature is minimum, and more brightness is of the filament is temperature is medium, and the high temperature is measured by the more darkness of the filament. These variations are to be measured the level of temperature. Okay, thank you.